Hello, ladies and gentlemen. Today we're going to take a look at rational exponents and radicals. How are these fraction exponents related to square roots and cube roots? So today we're going to discover that relationship. You also need to take some notes as we go along this video, as well as have a calculator ready. So let's talk about some notation. We're talking about radicals here, and radicals are that square root, cube root that you're familiar with. That symbol right there is a radical sign. Underneath the radical, you'll find the radicand. That is the stuff underneath. Sometimes it's numbers and variables. Now out in front of the radical sign, as a part of it, you're going to find a number that's called the index. That's the type of root it is. Now, on the other hand, we can have things called rational exponents. And what a rational exponent is, it's a fraction exponent. So this is 9 raised up to the 1/2 power. It's not 9½, it's not half of 9, but it's 9 raised up to the 1/2 power. This is a rational exponent, or a fraction exponent. So how are these two things related, and why do we want to work with these? How is this going to come about? Well, first of all, roots and fraction exponents have this sort of interesting relationship. For example, if you type in 25 raised up to the 1/2 power, it gives you a value of 5. 36 raised up to the 1/2 power gives you a value of 6. And 49 raised up to the 1/2 power gives you a value of 7. 64 to the 1/2 power gives you a value of 8. All of these are the square roots of those previous numbers, right? So the 1/2 power is the same thing as a square root. And the same idea holds true with a 1/3 power. This would be the same thing as a cube root of 8. The 3 is the index saying what type of root it is. And this would be 64 in the cube root sign. So roots and rational exponents have this relationship. Let's sort of summarize this part in our notes. How are they related then? Well, first of all, let's draw this little table. Rational exponents are those fraction exponents. We're talking about x to the 1/2 power. This means a square root. So in the radical notation, we would be writing a square root of x. Notice that the little 2 as the index is not written there because it's implied when we talk about a square root. Now x to the 1/3 power is the same thing as a cube root. So when I write that in radical notation, it is the cube root of x. And x to the 1/4 is a fourth root. That means we're talking about the fourth root of x. So the denominator of all of these little rational exponents here tells me the type of root or radical that I'm dealing with. So what does that mean if I was going to do, let's say, 8 to the 2/3 power? Well, let's take a look at that. We need to understand how to change forms from radical form to rational exponent form and vice versa. So in radical form, we're talking about things that have a square root or a cube root, the radical sign. In rational exponent form, we're talking about something that has a fraction exponent. So we want to be able to change from one form to another, and we need to understand how they're connected. Let's look here at the beginning where I have a rational exponent, and here at the end where I have a radical expression. So here, the denominator is the type of root I'm dealing with. Notice that the denominator here is the index on my radical sign. And the top, the numerator, is the power that radical is raised to. So let's practice changing from one form to another. For example, here we're going to rewrite each of these expressions into radical notation. So let's look at the first one. We have 7 to the 1/2 power. That means we're dealing with a 7 inside of a radical sign. What kind of radical is it? Well, let's look at the bottom here. It's a square root. I have that. And it's raised up to the first power. So what we really have here is just the square root of 7, right? Now look at number 2. We have 4 inside of a cube root. Notice the denominator raised up to the fourth power. Let's look at number 3. I have 2 inside of another cube root raised up to the fifth power. And we could continue this pattern here. 7, we have a cube root of 7 raised up to the fourth power. Number 5 here would be a square root of 6. Remember, the denominator is the type of root, raised up to the third power. And last but not least, number 6, the sixth root of 2 raised up to the first power. So this is rewriting into radical notation using a root sign, but what about if we had to go in reverse? Can we rewrite things in radical form using a rational exponent or a fraction exponent? Let's look at what that would be. So for number 1 here, we have 10 as the radicand, so we're going to start with that. 10, what type of root it is going to go on the bottom of the fraction. Notice we have a square root here. So we're going to place that 2 on the bottom. It's raised up to the 3 power, so we would place that in the numerator. So this is 10 to the 3 halves. Number 2, we would have 2 as the base. The type of root looks like it's a sixth root, and it's raised up to what looks to be the first power because I don't see anything else. Number 3 here would be 2 to the 4 on the bottom here, 5 on the top, 2 to the 5/4 power, and so on. The next one, number 4, would be 2 to the 1/3. Number 5 would be 10 to the 1/6. And number 6 would be 10 to the 7/3. So rewriting from one form to another, you might be thinking, why would we even need to do that? Well, many times to evaluate or to find an actual value for these in your calculator, one way may be more beneficial or efficient for you to know how to do based on your calculator. So that brings us to the part where we need to be able to type these values into our calculator. So 256 raised up to the 1/4 power. That is 256 raised up, use that little caret button, and you might have to type in 1 divided by 4 as all part of that exponent. Now everybody's calculator is different, and the best way to do this would really be to make sure that you ask me tomorrow in class how to type this in so that we can get these into our calculator correctly to get the right value. But you know you did it right if you got 4 as your answer. The 256 raised up to the 1/4 power is 4. And the next one with 32 raised up to the 1/5 power is just 2. So be sure that you know how to get those exponents in your calculator, whatever exponent button you use. And if you have a fraction button on your calculator, make sure to use that when you're typing in those exponents as fractions. Now, these scientific calculators, many of you have, so I just wanted to point out a few key things. This is the power button when you raise it up. And now here, the ABC button is that fraction button. So you type in 256 raised up to the 4, hit the fraction button, 1 divided by 4 here, and then you'd go ahead and be able to type that in as a fraction, okay? Now let's take a look at how we could input radicals into our calculator. So this is the cube root of -8. Now you might be thinking, well, we can't cube root that because it's a negative in there. Well, cube roots are different than square roots, ladies and gentlemen, and so what you know about square roots is true for square roots. But now when we extend our knowledge beyond just square roots, some of the rules that you're familiar with, we have to rethink those a little bit, okay? This is a cube root. We're asking the calculator what number times itself 3 times would give me -8. So if you were going to find the cube root on your calculator, especially these, there's a button for that. It's underneath the math button, so you'd have to hit math button first, and then it's one of the options listed on that screen. So we would type in the cube root of -8, and we should get a value of -2. That is because -2 times -2 times -2 does in fact give me a value of -8. And that's essentially what you're asking the calculator when you ask for a cube root. You're saying what number times itself 3 times would give me -8. So that value should be -2. Now, 625, the fourth root of 625, many calculators do not have a fourth root button. And this is why it might be beneficial to change its notation. So we could type it in probably faster as 625 raised up to the 1/4 power, because that's what this notation would mean. So we would get a value of like 5 here if we could type it in this way, but most calculators, like I said, don't have a clear fourth root button. You can, however, find generic root buttons underneath this math button as well, and we'll take a look at that in class. But what if we had to evaluate without a calculator? Let's say we aren't really familiar with some of these roots and how they all work and how to use a calculator, or let's say we don't even have one. Many times you can evaluate them without a calculator, and many times we're going to want to evaluate them without a calculator, so we need to have this perfect roots table. Now, if we didn't fill this out in class, let's go ahead and make sure that you did. You need to have all of your perfect squares listed. That is, what's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. Now, perfect cubes are just these numbers taken times themselves 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. That's how we're completing this whole table here. We're taking each of these numbers raised up to these powers here and going in and filling in this chart, if you will. This chart is going to be very handy to us later on, but it's also handy now when we're talking about this radical and rational exponent idea. So how can we evaluate these without a calculator? Let's say I have 25 raised up to the 3/2 power. Well, let's first understand what it is we're talking about here when we talk about 25 raised up to that power. We're talking about the square root of 25 raised up to the 3rd power, right? That's what this notation means. This is the type of root. This is the power it's raised to. So what is the square root of 25? Well, let's look at our table. We'll look under squares. We'll look for the number 25. We'll read across, and that number is 5. So this whole part right here becomes 5. So I really have 5 raised up to the 3rd power. What is 5 to the 3rd power? Well, let's look across now. 5 to the 3rd power is 125. So I don't need a calculator to figure that out if I understand all of my perfect roots here. Let's look at another one here, the second example. 125 raised up to the negative 2/3. Now notice a negative power. That means that this is happening on the bottom of a fraction. So I really have 125 raised to the positive 2/3 power. Now a lot of people like to get that confused. The 2/3 power doesn't flip over, guys. 2/3 is 2/3. He just becomes positive 2/3 when we move him to the denominator of that fraction. Now dealing with this now, let's go ahead and write what this represents. We have 125. Now this 2/3 means that I have a cube root raised to the 2nd power. So let's go ahead and figure out inside those parentheses, what is the cube root of 125? Well, let's look at that. Cubes, 125. The cube root of that is 5. And I have 5 then raised to the 2nd power. 5 raised to the 2nd power, I'll just look across, is 25. So this is 1/25. That's what this is equivalent to. Now, if you were to type this in your calculator, many times it would give you a decimal. But we want to evaluate it without a calculator to avoid that decimal approximation, to actually get that fraction notation that it really represents. So we need to be familiar with how these things are related, as well as how to use this calculator and this chart to help us find these values. We'll continue to practice this and you'll get better, but right now I hope that you understood the connection that we're making when we talk about roots and radical or rational exponents. So thank you very much, ladies and gentlemen, for taking good notes. Kincaid out.